Hello to my beautiful M436 class. I have somebody I'd like you to meet. This is Louie. This is Lou Barrett Scott, who we call Louie. And here he is in his Christmas jammies. He's joining me for this final exam review video. First I wanted you guys to see what was inside of me while we learned some of the material we're going to review together. I have great news for you guys. Louie wanted to be the first to tell you that trig is not going to be on your final exam. So those units that we did trigonometry are not going to be something that you're going to be tested on. Louie was really excited to tell you guys that. So we are going to review statistics, we are going to review probability, and we are going to review the normal curve, which are the big things that you guys learned that you are going to be tested on in your final. The other material that you've covered this semester will not be on this final. So, welcome. I miss you guys. I've been hanging out with this little one. I will be back February 3rd. So, I will be very excited to get back to you guys, but I'll miss this guy. All right, let's get to it. Say bye-bye, Louie. All right, ladies and gentlemen, so we are going to start the review actually by talking about the stats. That's what I taught you guys before I left, so that's where I want to start. So I'm going to start this this first video just talking about problem starting here in your final packet. So I scrolled past the very first part and we are on this page. I'm going to do most of these problems with you because a lot of them are really quick. So if you can recall back from when we talked about that R value, that's called the correlation coefficient. The R value, the correlation coefficient. And basically that's just talking about how strong the data is correlated. Is it positive? Is it going up? Is it negative? Is it going down? Is it kind of random, which would be no correlation? So the stronger the correlation, the closer we are to the number 1. If it's positive, -1. If it's obviously a negative correlation. And then the closer we are to 0, the less kind of linear it looks, essentially. Okay, so starting with R equals 0. So which one of these does it look like there's literally no correlation? We're not increasing a little bit or decreasing a little bit. And I would say that that's probably D. Because with C, it does look like that data is kind of going down. So I would say D is no correlation. And you're going to hear baby noises in the background. I have my son here with me, so my apologies. Let's see. Look at the negative numbers. So we have 0.2, which is pretty close to 0, and negative 0.65. So I would say, and there's no -1, but by the way, this R value would be -1. So I would say that the negative 0.2, which is pretty close to 0, is going to be C, because it does look like it's not that correlated, but you could technically argue that the data is going down. And then this one would be the negative 0.65. Okay, it's a little bit tighter together, but still 0.65 is kind of moderate in the middle there. So that would be B for this one. Okay, and then for the positive numbers, we have 0.83 and 1.0. So 1.0, that one's the easy one. It should look like an exactly straight line. So that is letter G. And then looking at the graphs, this data is kind of going up, but it's very spread apart. So that would be a little bit closer to 0, whereas this data is clearly tighter together. So I think it would make most sense to say that F is going to be the positive 0.83, which is pretty close to 1. That's all we're doing for that. And then the next part is true or false questions. So this is all about correlation. So if you scroll down to the very bottom of this review, this is what I would study in terms of correlation facts. Okay, I'm going to reference some of these facts while doing these true or false questions. So the correlation between a person's height and weight is 0.7. I would say that this is true. Generally, the taller you are, the more you're going to weigh. I understand that that's not always true, right? Like if, you know, you might be tall and very, very thin, so you might not weigh as much. I understand that that's a possibility. Or you might be short and stout, and so maybe you weigh more. I don't know. But in general, the taller you are, the more you're going to weigh. You don't like that one, do you, buddy? Okay, so that one I'm going to say is true. The next one says the correlation between someone's gender and salary is 0.9. Okay, I know that you may argue, I don't want to get into like a gender gap discussion here. I understand that that exists, but in terms of statistics, okay, we cannot measure an R value or a correlation with categorical data, and gender is going to be a categorical data. So this is going to be false because gender is categorical. So all I'm saying here, I'm not saying that there's no correlation. There might be a correlation with gender and salary, but we cannot put a number to that correlation, if that makes sense. So we cannot say that that correlation actually is 0.9. You could say that there is a correlation in general, but you can't assign a number. Okay. All right. So that one is false. Again, because we cannot assign a number. All right, the correlation between a person's height and age is negative 0.56. All right, so I understand that there's like a plateau you eventually hit, but think about when you're young. So like my children, for example, the older you get, the taller you get. So it wouldn't make sense that this is a negative correlation. A negative correlation would mean the older you get, the shorter you get. And that's not the truth. I guess you could argue at the end of your life, you start shrinking again. Let's just think about in general. So think about children. The older they get, the taller they get. So I would say this one's false. It should not be a negative correlation. Oh, buddy, let me get you a pacifier. Here you go. You don't like that one. Okay. So then the next one says the correlation between sunshine and inches of rain is 1.34. So right away, this is false. I really don't know what they mean about sunshine. I don't know how you can measure that with a number. But the reason why I said right away this is false is because correlation falls between the numbers -1 and +1. So anything over that, it's an automatic false. So for example, I mean, this is 1.34. That's bigger than the number 1, automatic false. All right, last one. The correlation between the weight of a car and miles per gallon is -0.8. So the more the car weighs, the less miles per gallon they get. I don't know much about cars, but I do think that that's true. You can't go as far the more you weigh. So if you're a car person, you can correct me if you think that's wrong, but I do think that this would be a negative correlation. All right, let's move on to calculating residuals. So I don't know if you guys remember this formula, but it is one that you'll need to know. The residual formula is y minus y hat. Okay, so the y is the actual data. Sorry about my handwriting. I have one hand on a pacifier, one hand on this iPad. That is the mom life. All right, so that's the actual data. And then this is the y hat is the estimated data using, or the estimated value using the formula they give you for y hat. Okay, so I'm going to do just one of these examples. You'll do the second one on your own. I'll do number 11. You try number 12. So it says the data value is 8 and then 12.7. So this is the y value because that's the real data. So that is the y value. The linear regression line, they give us the equation. So to find the y hat value, what I'm going to do is I'm going to take 8, the number 8, and I'm going to plug it in. I'm going to plug it into the x, right? there. And that's going to give me the y hat value, the estimated value when x equals 8. So when x equals 8, I get 16 minus 3, which is 13. So that's the y hat. To calculate the residual, I'm going to take the y value, the original real data, minus the y hat, the estimated, and that gives me my residual, which is negative 0.3. Okay, that's the answer. If the question then said, is the data value above or below average, we would say it's below average because the residual was negative. All right, you guys try the next one on your own. Okay, so for this next one, you will have a calculator. So you're going to go into Stat Edit, and you are going to clear out your lists. Oops. Clear out your list however you need to in your calculator and enter your data. So as you can see in the calculator, I am entering the data. My L1 values are the left column, so 5, 12, 3, 0, 10. All right, and in my L2, I'm going to put in the test grades. Great. All right, so this is homework assignments completed compared to the test grade. Calculate the R value. We're going to go to Stat, Calculate. Oh, you know what? Stat, Calculate, it always does that. That's not the one I wanted to do. There it is. Okay, so let's try that again. Sorry about that, guys. Stat, Calc, Lin Reg. That's the one that's going to give me my R value. So my R value is the very bottom one, so 0.919. So we can say 0.919. And that just means that there's a very strong linear positive correlation. It says calculate the least square regression line. So it actually gives me up here, where it says y equals ax plus b, it gives me the formula, it gives me the a value, and it gives me the b value. So I just have to plug and chug. So the least squares regression line, again, it's Stat, Calc, Lin Reg, enter. And I don't know why my iPad's acting up, but y hat is ax plus b. So 3.36 x plus 58.95. Okay, there's my least square regression line, and it says find the residual for 6 assignments completed. So here's the real data. 6 assignments completed got the person an 84. That is the y value. Oh my goodness, it's driving me nuts. So we're going to take 84 minus the y hat. Well, to find the y hat, I'm going to plug in to this formula, and I'm going to plug in 6. So what's my predicted score for 6 hours, or for 6 assignments? 3.36 times 6 plus 58.95. And notice I'm just going to plug that into my calculator. 3.36 times 6 plus 58.95 is 79.11. That's the predicted score. So 84 minus 79.11 is 4.89. That's the residual. And that means that the person did above what was expected. Okay, so now the last part of this, I am going, oh, there's a couple parts left, but for this one, we give you the formulas. You will be given the formulas on your test. So don't freak out. You're going to be given the formulas. This is how this is a different way to calculate the A value or the slope of the regression line, and this is another way to find the B value. And I'm just going to give you everything. So it says calculate the slope. The slope is A. So the formula for that is R times SY over SX. So R times SY over SX is, the R value is 0.79. SY is 2.6. SX, 1.8. Literally type this into your calculator exactly how you see it. Times, I would probably do parentheses, 2.6 over 1.8. Oops. And that is 1.14. Oh my goodness, why is my iPad? Okay, so that is my slope. I'm going to just throw this iPad. I think it's my stylus. Hi, buddy, I know. Okay, now calculate the y-intercept. The y-intercept is the B value. So part of the studying is just knowing what's what. Okay, so the B value is y bar. It's for sure the stylus. So I'm going to use my finger. I'm sorry, this is a little sloppy. And then minus A times X bar. Okay, they should give you all of this. So Y bar is 15. A is what we just found, so 1.14 times X bar, which is 9.5. Okay, 15 minus 1.14 times 9.5 is 4.17. Louis likes to be held, so he wants me to hold him. All right, equation, y equals mx plus b, or ax plus b in this case. And that's that. So this is and it's y hat. Okay, so y hat equals the a, which was 1.14x, plus the b, which was 4.17. That's the answer. All right, last part is just this true or false. This should be really quick. So given this graph, answer the questions. There's a positive correlation, true. And the reason is because the line of best fit, or the regression line, has a positive slope. The y-intercept is 25. Definitely not. False. The correlation could be 0.7. I would say that's true. It could be. It's pretty tight together, the data. If the red circled outlier is removed, the slope will increase. Let's take a look at this. So if this is removed, I actually think the slope would decrease. I think if this wasn't here, then I think the line of best fit would kind of, The line of best fit's kind of, I think it would kind of remain the same. I think the slope would decrease and the y-intercept would increase. So I think it would be a little bit more like this. So the blue line is what would happen if we took out that. So the slope would actually decrease. I hope you guys see what I mean. So think of the line of best fit as like you want an even number of dots above and below the line. So if that red dot wasn't there, it would change things like this. And then that would mean that the y, see how the y-intercept of this would be higher, so that would increase, so I would say that's true. Check the answer key to make sure I'm right on that one. A little rusty. All right, so I basically did the whole stats section with you. I know this was a long video, but hopefully it's a good review and refresher of what we talked about before I was gone. All right, thanks guys. The next video we'll talk about probability.